Good morning. We're going to start by kind of, I'll review really quick about some of the stuff that we talked about on Friday. But, so we've got a couple of different spheres within the Earth. We've got your atmosphere, which is all of the air and dust particles and water vapor and things like that surrounding planet Earth. We've also got the actual geosphere, which is going to be the layers of the earth, and you have the hydrosphere, which is going to be all the water kind of on earth and the oceans and the rivers and things like that. So the geosphere, we started with the inside and we worked our way out. So we have the core, which is broken down into the inner and outer core. And it's made up of nickel and iron. The inner core is solid due to the immense amounts of pressure found from the other layers pushing down on it, so it forces it into that solid state of matter, the inner one. And then the outer core is going to be more liquid-like. So then we did the mantle, which is made up of molten rock or liquefied rock. And we talked about the difference between magma and lava, and it's just their differences in where they're located in the whole grand scheme of things. And so the magma is below the ground and lava is above the ground. So and then we talked a little bit about the convection currents when a warm air, or in this case warm rock, rises because it's less dense, so it's lighter, and then it's going to get cooler because it's getting towards the surface of the earth, and then it's going to sink because it's cooler, so it'll sink then. And so then as it gets closer back to the center, it's going to heat back up and start rising again. So, and it's these convection currents that are responsible for the plate tectonics to move up above. So, okay, here's the new stuff. We've got, excuse me, your crust, which is called your lithosphere. And actually, your lithosphere is really the crust plus the top portion of your mantle, just the very, very top portion. And so that's what the crust is, but technically the lithosphere contains that top layer of the mantle. It's broken into pieces called the plate tectonics. Sometimes they're called tectonic plates. They're the exact same thing. So the one that we're located on is the North American plate. So and it's called North American plate because it's got the entire continent on there, not every single, most of the continents, their plate is named after them. So Italy is kind of different. I don't remember here. I have a picture. I do. Okay, I'll show you. I'll show you Italy here in just a minute. So when the plates move, because I'll show you the picture in just a second, you can get earthquakes, mountain and trench formations, volcanic eruptions can occur. So all of that can happen. Depending on which way the plates are moving, by the way. So here's a picture. So right now we're located on this plate right here, which is the North American plate. This plate right here is called the Juan de Fuca plate. It's a little tiny guy. He's located right here along a very a notable area in the United States. It's called the San Andreas Fault Line here. So the Pacific plate and the North American plate typically rub up against each other. Saying it's the North American that goes up and the Pacific plate moves down, and then that's why there's lots of earthquakes that occur there. Now, Italy's a little different. Okay, it's playing tricks on me. Here you go. I don't know how well you can see this picture, but Italy's right here. Kind of off the, it's technically on the Eurasian plate. However, the African plate here is moving also. And so what's happened is the Eurasian plate and the African plate moved, because technically the very, very bottom parts of Italy are actually on the African plate. And then the top most of Italy is going to be on the Eurasian plate. But as these plates have moved, it's actually broken, because you can kind of see how this juts out and then it curves around up here. So technically the African plate comes all the way up here. And so it's not a very, I mean, it looks like it's maybe about the size of Italy, but in the grand scheme of things, that's width-wise. It's not a lot of width. And so when it's moved, it's broken these two into smaller pieces or different plates. And so technically, they're saying nowadays that Italy is on what's called the Adriatic plate. Sometimes it's called the Apulian plate, but Adriatic plate. And so it's just a piece that's broken away from the Eurasian plate, basically. So kind of interesting. I had to look that one up because I didn't know that one, because we don't normally talk about the geology of Italy. So, but it was kind of neat to learn about that. So, and maybe you already knew that. Maybe they've taught you that, and I'm just telling you something new or something the same. So, okay, Pangea. I don't know if you've heard of Pangea before, but basically this is the name of the big continent that scientists think used to exist way back when, because they believe that at one point in time all of the continents were one gigantic continent, and they named this gigantic continent Pangea. So then they believe that due to all of the movement by the plates, that the continents have drifted apart from one another. And this is called the theory of continental drift. And it was proposed by a gentleman by the name of Alfred Wegener, or Wegener. So the reason why they think this is, number one, if you look back here, it seems fairly, usually when people look at the maps, they see a resemblance of South America and Africa. It looks like South America could have been nudged right up there. The idea is that at some point they were connected, and then these two plates moved away from each other. With this right here, they have found fossils and rocks on this eastern side of South America that match the fossils and rocks found on the west coast of Africa. And similar dates, similar fossils found in them, and so that's why they believe that at some point that's one piece of evidence that they have as to the fact that there may have been they may have been connected at one point in time. There are a few fossils and rocks that are similar between this western coast of the United States and the eastern side of Asia as well. That kind of leads people to think that maybe that they could have all been connected in some point. So, but this is a theory, so it's not a law or something like that. So, okay. So this is kind of a picture of Pangea right here. You can't really see these, but it's telling you the different times. I think this is the Triassic time period. This would have been the Jurassic, Cretaceous, and present day. And I honestly don't know what that one is. It's going to be before. That's probably Paleozoic, would be my guess. So everything was kind of one big blob, and then when they split apart, and they actually named these two. This is Laurasia, which would have been the United States and Europe and Asia, and then Gondwanaland, which I always thought was a funny name, but that would have been South America, Africa, India, Antarctica, and Australia. And then you kind of see India is moving closer, and then it eventually ends up right here. So again, this is a theory. No one was around back then, so we don't really know with any absolute certainty. So, but yeah, so now we're going to talk a little bit about the plate tectonic movement. When we talk about plate tectonics moving, they don't move a lot. We're talking a couple of centimeters, if that, a year. They're not going to move like meters or something. So, divergent boundaries, I told you we kind of talk about these. Divergent boundaries is one way that they can move. And divergent is when they pull apart. And so because they pull apart, the crust is pulling apart what's underneath, mantle. What is the mantle made of? Magma. So when they pull apart, they're going to have that magma come up and fill in the space. But oftentimes it doesn't happen very quickly, obviously, with them only moving a couple centimeters, and so they don't fill it all the way up. So what we end up with is not a complete smooth surface because all of that magma comes up. Usually we form these things called trenches, sometimes ridges. So one of the more common ones is the Mid-Atlantic Ridge, which is located between the North American and Eurasian plates. And I'll come back to this, but Mid-Atlantic Ridge, kind of out here, because these two plates are moving away from each other. So, so our oceans have quote-unquote grown as these particular continents have moved further apart. So I don't have any pictures of a oh, I do. Just kidding. I thought I didn't. There's one where I don't have a picture. So this is a picture of a divergent boundary it's very well known. It runs through Iceland. So Iceland is in the middle of this boundary. So actually, Iceland is growing. Most continents don't grow, but Iceland is. So because this plate here, these two plates are moving away from each other, and so you get more mountains and trenches or ridges being formed here. So, and this is a picture. So from Iceland. So that's a one of those ridges. Now, like I said, it's not going to fill it in completely. So there is solid ground down there, but since you're only, moving a couple centimeters a year, it's not going to just flow up really, really fast. And so that's why you get these what look like trenches, but they're called ridges. So, but that's one very well-known divergent boundary. Okay. The next one, convergent boundaries is when they converge or they come together. And so there's a couple of different things that can happen with a convergent boundary. The first thing that can happen is you can have an oceanic and a continental plate meet together. So basically one where an ocean is and one where land is, and they converge. You can also have one where you've got two continents converging. The Indian plate converging into the Eurasian plate would be an example of that. And then if you've got oceanic and an oceanic plate converging with another oceanic plate, that could be the third option. So generally, one plate will be subducted and go underneath, but occasionally they can join together and both can go up, and then and that would form mountain ranges. So for example, so that's going to happen with the continental plates, or the continental plate of India and Eurasia, because you've got the Himalayan mountains along the upper northern border of India. So, but if not, one plate's going to be subducted and go underneath the other one, and I believe the continental always goes on top, because I believe that's the one that's less dense. It might be the other way around. So you get this trench or this fold, I guess, in the ground. So your Philippine plate subducts under the Pacific plate. So I guess that would mean that continental plates are more dense and the oceanic are not. So Philippine plate here, Pacific plate here. So the Philippine plate subducts underneath your Pacific plate. So this one is more dense than this one right here. So that is where the Marianas Trench is. Very well-known trench. I think I have a picture. Maybe. Nope. Okay. Apparently I didn't. I looked for pictures on that one. I guess I didn't get that one. So we'll come back to that. Then for you, because we don't have any other than Hawaii, but that's totally different. It's a hot spot, not a plate tectonic movement. But you've got Mount Vesuvius and Mount Etna in Italy, and they were formed by the subduction of the Eurasian and Arabian plates colliding with each other. So I'll go back up here. I should have put these next to each other. So Arabian plate and Eurasian plate pushing against each other. So I don't know if you've seen Mount Vesuvius or Mount Etna. I haven't ever seen Mount Etna. My husband and I saw Mount Vesuvius 2 years ago, and it was kind of cool to see Pompeii. So I mean, obviously very well known, but Etna is also a very well known eruption as well. Um, so the last thing about convergent boundaries is that the movement can also form undersea volcanoes. So the left side of the Pacific Plate um, and the northern and southern are just covered with um, volcanoes. So you can also get mountain ranges. So the Himalayan mountains, like I said, between India and Nepal and China. So, um, so here's a better picture for you. For oceanic to continental, so yeah, I was right. The oceanic crust goes below. I'm sorry. So this is a little more dense, so it goes down, and this guy goes up. And so you can see this fold here. This is called a trench. So it's a little deeper, and that's how you get that one. So, and because of that, going under, it's not uncommon for there to be volcanoes, as that crust is going to have nowhere to go but to kind of move up, and the mantle here is going to get pushed up. Same thing over here with the continental to continental. You're going to get mountain ranges being pushed up, and then here is oceanic to oceanic, and you still get a trench down here. So this was the ring of fire that I was talking to you about. So lots and lots of volcanoes popping up here around the corners. So, and here there's mountain ranges because the Nazca Plate is colliding with the South American plate, and that's why we've got the Andes Mountains here all along South America. So, kind of tells you why we have some of these natural wonders. So the last type, so we've got divergent, which go away, two plates go away, convergent, where they come together. The last one is a transform fault boundary, where two plates slip past each other. So the fault line is actually where they actually touch and rub past each other. So there's, like I said, the San Andreas Fault is the really well-known one here in the United States. But you actually have two fault lines out in Italy. I couldn't find names for them. Maybe you already know this. They didn't. I couldn't really find any names on them, but due to the plates moving, and you have that Adriatic plate now, but due to them moving, you now have a fault line running from like Genoa down south. And then you've got another fault line running this way. So there's no specific official plates there. Like I said, you're sitting on top of a different, like a piece of one of the major plates. You're sitting on top of one of the pieces of the Eurasian plate, but because it's kind of broken up, that movement, because it's broken up, you now have two major fault lines along in Italy. So, but yeah, I really couldn't find a name for it. So I don't know if you guys have a name for it, or if I just couldn't find it, or maybe you don't have a name for it. So, but I was able to find a little bit of information on your homeland. So hopefully it's stuff that hopefully you're getting some stuff out of it, it's not stuff that you've already learned. So if it is, I'm sorry. And then here's a picture of the San Andreas fault line here in the United States. So like I said, Pacific plate moves up, North American plate moves down. So okay, last little bit. Fossil record. We use fossils to help us determine how old the Earth is. So what a fossil is just a piece of dead organism that's been preserved in sediment. So, it could be a plant, it could be an animal, it could be anything. They might leave an impression like a mold. They might leave um, the actual fossil, like the bone behind or something. So, so this is how we were able to come to the theory of Pangea because we found those, like I said, the similar fossils and rocks on Africa and South America. So, oh, that's it. I thought I went into relative. I think that was on the last one. That's right. So that kind of wraps that one up. Sorry, I thought I had one more slide, but I didn't. So, um, if you have any questions, just let me know. If this is all stuff that you've learned before, let me know, and I'll try to go a different way. But hopefully, you learned something new here. But as always, if you have any questions, don't hesitate and just let me know. Have a good day.